Consider the ionic compound GOFX3. GO is a group 3A metal that is found as a liquid at room temperature and pressure and forms a 3+ cation. FX is a group 7A nonmetal and is found as a diatomic gas at room temperature and pressure. Write the Born-Haber cycle for GOFX3 and calculate the bond dissociation energy of FX2 using the following data for the formation of GOFX3. Before we begin, I'd like to say that we will be putting the delta H for every step on the side as we go along. I'm not going to do it as a second step. So, first, we have to change GO from a solid to a gas. So we use the evaporation. We use that, and now we have to make it into GO 3+ gas. So we will use the ionization energy 1 to get to GO+. We will then, in a second step, go to GO 2+ with the second ionization energy, and then we will do the same thing to get to GO 3+ gas using the third ionization energy, and we must remember each time to add an electron on the right. In the second step, we will we will be using 1/2 FX2, which we will multiply by 3 because in the problem there are 3 FX gas, which turns into 3 FX gas, and we do not know the bond dissociation energy, so we will just put a question mark there and multiply that by 3/2. Then we will go to the we must change that into its ion, and we will use the enthalpy of electron affinity, which will turn our 3FX, and we will make sure we put our electrons on the left, our 3 electrons, to 3FX minus gas, and we must make sure to remind ourselves to multiply the enthalpy by 3. Finally, we will add our lattice energy, and we will use GO 3+ plus 3 FX minus to get GO FX3, and we will put in our lattice energy, and then we must cancel everything out. With the highlighter colors match means that those two cancel each other out, and we end up with GO plus 3/2 FX reacts to form GO FX3, which is what we were looking for, so that works out good. And then we put the enthalpy of formation, which we are given, on next to that. So now we have all of our information, so we know things we have to multiply by. So now we're going to make a formula for the enthalpy of bond dissociation energy by first we will write what the enthalpy formation equals, and then we will rearrange that to solve for the enthalpy of bond dissociation energy, and then we will plug in all of our numbers, solve using a calculator, and we will get our enthalpy of bond dissociation energy equals positive 47.2 kilojoules per mole.